Next we'll see is the representation of function. How a function is represented. First is verbal form. How do we represent a function? These are the various types. First is a verbal form. Your output is one more than twice the input. Okay, if this is a function, then what is the domain? Domain is the set of all the inputs. And what is the range? Range is set of the output. The second form is arrow form or Venn diagram form, which we are already seeing. This is set A, this is set B. Your domain is the set of pre-images. See, the first set is called the domain. It is also called as pre-images. Then range is the set of images. Okay, this is the range. The next is ordered pair x comma y. If f is equal to 2 comma 5, 3 7, 4 9, 5 11. Your domain is the set of first components from the ordered pair. See, this is the ordered pair. Out of this, the first components 2, 3, 4 and 5. This is called the domain. And the range is set of the second components from the ordered pair 5, 7, 9 and 11. They are called the range. Next is the rule formula. Y is equal to fx and it is equal to 2x plus 1, where x belongs to natural numbers and x is between 1 and 6. That is, x is greater than 1 but less than 6. Fx is read as f of x or function of x. Here what is the domain? Domain is the values of x and range is the set of values of y for which fx is defined. So values of x is the domain and values of y according to this formula is the range. Next is the tabular form. Here you see a table. Here is the value of x and here is the value of y. Domain is the values of x and range is the values of y. And the last one is graphical form. Here we have the y-axis and this is the x-axis. Like we put on the graph, we'll put numbers on both the axes. Here see, the domain is extent of graph on the x-axis. See, the x-axis is this. So all the numbers on this graph on this axis is called the domain. And range is the extent of the graph on the y-axis here. That is called the range. So in different forms we have seen what is a domain and what is a range. Let us go through this example. Which sets of ordered pairs represent functions from A to B? The set A consists of the elements 1, 2, 3 and 4. Elements of B are -1, 0, 1, 2 and 3. Now we have the set of ordered pairs. First is 1, 0, 1 from A and 0 from B, like that. 3, 3, 2, -1, 4, 1, 2, 2. Now here if you see clearly, this does not represent a function. Why? Because see this one, 2 -1, that is 2 from A and -1 from B, and 2, 2, that is 2 from A and 2 from B, shows that the element 2 which belongs to the set A has been assigned 2 images of B, One is -1 and the other is 2. From the definition of functions, clearly it says that elements of A, one element should be connected to one element of the other set. But here, one element is connected to two elements of B. So this is not a function. Okay. See the second one. 1, 2. Here 1, 2, 2 minus 1, 2 minus 1, 3, 1, 3 from here and 1 over here, 4, 3, 4 and 3. This represents a function. Why? Because every element of the set A has a unique image in the set B. All elements of A are assigned values in the set B. This is a function. See the third one. 1, 3. 1, 3. 4, 1. This is the 4 here. 4 and 1. 2, 2. 2 with 2. Now this does not represent a function. Why so? Because 3 here, the element of A, is not assigned any value in the set B. It does not have an image in the set B. Hence this is not a function. The fourth one is 1, 1. Here 1, 1. 2, 1. 3, 1. 4, 1. This is a function because each and every element of the set A has been assigned a unique image in the set B. Alright. Let us see the second example. Evaluation of a function. Evaluate f(x) is equal to 2x square minus 3x plus 4. This is the function. We have to evaluate it when the value of x is 7. This is the first question. And the second question is when the value of x is minus 2t. So here this is nothing major. You just have to substitute the value of x as 7 in the first part. What is f(x)? f(x) is this entire function. In every place of x, you will put 7. So f(x) will become f7. See, wherever there was x, we are going to put 7. f7 is equal to 2 into 7 square. See, 2x square becomes 2 into 7 square minus 3 into 7. 3x becomes 3 into 7 plus 4. This will be equal to 2 into 49 because 7 square is 49. 3 into 7 is 21, so minus 21 because there is the minus sign, plus 4. 2 into 49 will give you 98 minus 21 plus 4 as it is. So f7 is 81. As simple as that. Now similarly, like you have solved this, you will now substitute the value of x as minus 2t. So f(x) will become function of minus 2t equal to 2 into, now what will you put in place of x? Minus 2t. If there is a square, give it a square. Minus 3, in place of x you will put minus 2t plus 4. First square this bracket, it will give you 4t square. Minus 2 square is positive 4, t square is t square. So 2 into 4t square, minus minus will become plus, 3 2s are 6, into t 60 plus 4. When you open this bracket, it will give you 8t square plus 60 plus 4. So this is very simple. Here check if the following relations are functions. See the first set, 2, 1, 0, minus 1, minus 2. This is the second set, minus 3, 2, 1, 5, 6, minus 1. Now this is a function because every element of A, as you can see, all the elements of A, each and every element of the set A has been assigned a unique element in the second set B. See, nothing is missing or left over in the first set. So this is a function. See the next one, P, Q, R, S. The second set is A, B, C, D and E. Here P is assigned to A, Q with C, R is assigned to two values in the second set, B and D, and S is assigned only one value, E. So this is not a function because the element R is assigned two values, more than one element in the set B. So this is not a function.